This is a problem for which I've got a number of questions. All right, I have 2 point charges, Q1 and Q2. Now, when they say point charges, we're talking about we don't have to worry about the size, we don't have to worry about the distribution of the charge, that we can assume all the charge is concentrated at a single point. So I have Q1, Q2, and in the problem here that they say that they are 3 meters apart. The total charge, so Q1 plus Q2, the total charge is 20 microcoulombs. And then one of the questions is if the force between them is repulsion. Now, if it's repulsion, you know that they have to be the same sign. They're either both positive or both negative. But because I know the total is positive, this would imply that Q1 and Q2 are both greater than 0. If the force is 0.075 newtons, if that's the magnitude of the force, and we already know it's repulsion, what are the two charges? And so this is a matter of setting it up. I know that the force, K Q1 Q2 over R squared, is equal to 0.075. And the sum is 20 microcoulombs, and that would, I guess that would officially newtons. We can go through, and it's a matter of two equations, two unknowns from this right here. Now, to simplify this from a writing point of view, instead of using Q1, Q2, I'm just going to let that equal A and that equal B. So A plus B is equal to 20 microcoulombs. And then I have Q1, or from here, A times B is equal to 0.075 R squared over K. And I know R, I know K, and so solve. And what I'm going to do is I'm going to solve for one of these. Doesn't really matter which one. A is equal to 20 times 10 to the negative 6th. That's the micro part. That's the 10 to the negative 6th minus B. Plug that into here. A, which is 20 times 10 to the negative 6th minus B, times B is equal to 0.075 times 3 squared, divided by 9 times 10 to the 9th. Now distribute. So I have 20, I'm going to do the shorthand, 20 negative, E negative 20, and this E from the calculators is the times 10 to the B minus B squared is equal to that. And let's actually get a number here. 7.5 times 10 to the negative 11th. And notice that I have a quadratic term here, and so I'm going to be dealing with a quadratic equation. So probably the easiest way to do it, if I cannot see how to factor it immediately, is to use the quadratic formula. So to do that, I need to set it equal to 0. So I'm going to move everything over to the right-hand side. So I have 0 is equal to b squared minus 20e negative 6b plus 7.5e negative 11. So b is going to be equal to 20 times 10 to the negative 6 plus or minus the square root of that squared minus 4 times 1 times c, 7.5 times 10 to the negative 11th, over 2 times 1. And so this becomes 20 times 10 to the negative 6th, plus or minus the square root of 1 times 10 to the negative, let's see, it's 3, 4, 5, 6, 7, 9, 10, negative 10th, over 2. This right here, the square root of this is 1 times 10 to the negative 5th, which is 10 times 10 to the negative 6th. So I end up with b is 30 times 10 to the negative 6 over 2, or 10 times 10 to the negative 6th over 2. Which is 15 times 10 to the negative 6th, or 5 times 10 to the negative 6. This actually could have been factored since these numbers come out so nicely here. So this becomes 15 microcoulombs or 5 microcoulombs. And because there was no way really to differentiate between the two charges here, one of the charges is going to be A, the other one's going to be B. So it doesn't matter which one you pick to be B because A is the other one. So those actually are the two solutions. Actually with units, I may as well circle these up down here. So that's the value of A and B.